Welcome to this presentation on inductive reasoning, a powerful cognitive process that helps us make sense of the world around us. Inductive reasoning involves drawing general conclusions based on specific observations, patterns, or evidence. Now, you all are welcome to this presentation with the title of Understanding Inductive Reasoning, with the theme of Exploring Inductive Reasoning and its relation to mathematics. Before we start, here is the flow of our presentation together with the objectives. Now, inductive reasoning. Inductive reasoning is a type of logical thinking that involves making generalizations based on specific observations or evidence. For example, I observed that the first three terms of a sequence are 2, 4, and 8. Therefore, I might conclude that the sequence follows a pattern of doubling each term. So, inductive reasoning typically works with observation, pattern recognition, generalization, and application. Inductive reasoning begins with observing specific instances or examples. Through this observation, patterns or trends are identified. Based on these patterns, a general conclusion or hypothesis is formulated. Now, the generalized conclusion is then applied to other similar situations or cases. For example, if you observe that every time you drop a ball, it falls to the ground, you might generalize that all objects fall to the ground when dropped. This is a basic example of inductive reasoning.
Let us now dive in a real-life example of inductive reasoning. Let's meet Carlos, a street vendor who sells fruit in the market. He wants to use inductive reasoning to understand the relationship between the weight of the fruits he sells and his earnings. Let's take a look at Carlos' observations. He recorded the weight of the fruit he sold each day and the corresponding earning. Here's what he found. He notices a pattern in his observations. As the weight of the fruits he sells increases by 1 kilogram, his earning increased by 50 pesos. This pattern holds true for each subsequent day. Based on this pattern, Carlos can use inductive reasoning to predict his earnings if he sells 7 kilograms of fruits in a day by adding 1 kilo to the weight of the fruits and multiplying it by the earning increase, which is 50 pesos. Carlos determines that his earning would be 350 pesos if he sells 7 kilograms of fruit in a day. Carlos' use of inductive reasoning allowed him to predict his earning without directly observing it. This approach is valuable in mathematics in real life because it helps us make informed predictions and draw conclusions based on the patterns and observations.
Inductive reasoning in our everyday life. We use inductive reasoning when making predictions about the future based on our past experiences or by drawing conclusions about people's behavior based on the patterns that are observed. For example, if you see every time it rains, the streets get wet, so you might conclude that the rain makes the streets wet, even though you haven't seen every instance of a rain making the streets wet. And another example is, every time you forgot to do your homework, your teacher will warn you. So, in this observation, you might conclude that whenever someone forgets to do their homework, the teacher will give him a warning. So, inductive reasoning plays a crucial role in our daily life by allowing us to make generalizations and predictions based on our specific observations or own experiences.
Inductive reasoning has strengths and limitations. Its strengths include flexibility, creativity, and applicability. It allows for adaptability to new information, foster new ideas, and is widely used in research and
So, what is the contribution of inductive reasoning to problem solving in decision making? So, in problem solving, inductive reasoning helps generate hypotheses or potential solutions, while in decision making, it provides a framework for weighing evidence and making informed choices, especially in situations with incomplete information.
Inductive reasoning. So inductive reasoning plays a significant role in mathematical thinking and problem solving. So it is the act of making generalized conclusions based on specific scenarios. So here's how inductive reasoning relates to mathematics. So first one is the pattern recognition. So it aids in recognizing recurring patterns within mathematical structures like numerical sequences or geometric arrangements. So second one is hypothesis formulations. So this serves as the starting points of further investigations. So third one is conjectures and generalizations. So it often leads to the formation of conjectures, which are statements believed to be true based on observed patterns. So the fourth one is problem solving. So it guides problem solving by providing insights into potential strategies in finding solutions through drawing with patterns. So the fifth one is empirical evidence and experimentation. So it primarily obtained through observation or experimentation. So the last one is educational approaches. So in mathematics, educators often employ inductive reasoning to foster students' problem-solving skills. Through engaging activities and exploratory tasks, students are encouraged to observe and formulate patterns for them to promote deeper understanding and critical thinking.
So in conclusion, inductive reasoning, it can be used to make predictions, but it should never be used to make certain claims. It allows you to work with a wide range of probabilities. It presents you with a starting point so you can narrow down your assumption and reach an informed conclusion. So like for example, if you notice that every time you eat spicy food, you get a stomach ache, you might use inductive reasoning to conclude that spicy food causes stomach ache. So, in a broad sense, inductive reasoning is when you start with specific observations or facts and infer a general rule or conclusion from them.